My name is Supriya. I have done my master's in chemistry. I have nearly 3 years of experience in teaching chemistry. I have given classes to both UK students from year 9 to year 11, both foundation and higher levels. And I have also given classes to the NEET aspirants in India and to the Canadian students also, which are preparing for MCAT, which is also a medical entrance exam. So, and today I choose a topic from chemical bonding. So let me share my screen. Okay, let's start the chemical bonding. So first we need to know what is chemical bonding. So what is a chemical bond? Chemical bond is simply a force that acts between two or more atoms to hold them together as a stable molecule. And the cause of chemical bonding is if any atom have tendency to acquire a state of minimum potential energy, or it can be if someone wants to complete its octet. Okay, let's discuss these two topics one by one. First one is the tendency to acquire minimum potential energy. Then what does that mean of acquiring minimum potential energy? See, when two atoms approaches each other, the nucleus of the one atom will attract the electron of the another atom. Okay, see, let's say there are two atoms, A and B. If they are attracting each other towards themselves, that means they are doing some work. And whenever something does some work, that means it is losing energy. We can consider it as our system, and whenever a system do some work, that system will lose some energy, and due to which the overall energy of this system will decrease, and on that basis you can say that it will stabilize after bonding because of releasing of some potential energy. Okay, and there will be two factors working here. First one is, let's say this is the nucleus of atom A, this is the nucleus of atom B. So the nucleus of atom A will be attracting the electron of atom B, and the nucleus of B will attract the electron of A. There is one more factor which is working here, is the repulsion between the nucleus and the electrons of A and B. Now, if the attractive force overcomes the repulsive force, then the total energy of the system will decrease because they are doing some work to attract each other, like to pulling each other towards themselves, and a chemical bond will form. Energy released in the bond formation is known as bond energy, and that bond formation is exothermic always. This is important, and it is exothermic because it is releasing the energy. Okay, now next thing is energy versus internuclear distance curves. Let's say these are two atoms A and B. When they are far apart, their energy was like more. When they tend to come towards each other, their energy will start decreasing. And when they overlap each other, like when they form bond, a chemical bond, their energy will be minimum in that case. This is the minimum potential energy which they acquire after forming the bonds. Now, for chemical bond formation, the conditions are the attraction should be maximum and the minimum, like the potential energy should be minimum here, and both conditions are fulfilled here, so bond will form. Second condition was tendency of an atom to complete octet. Every atom has a tendency to complete its octet and acquire nearest inert gas configuration. In the periodic table, except noble gas, each atom have around, you can say, incomplete octet, then they always react to complete that octet. That's why they are reactive and try to form bond. And to get that complete octet, the atoms can lose or gain electrons, or they can even share electrons to complete their octet. But in case of hydrogen and lithium, they will complete its duplet because they don't have p-d orbitals in them. So they will complete their ns orbital only, which will be 1s. Now, atoms can complete their octet in following ways. First one is they can lose or gain electrons. by complete transfer of electrons. And in that case, ionic bond will form. For example, here, sodium have one extra electron in its octet, while the chlorine needs one more electron in its shell. So what they can do is sodium can lose an extra electron, while the chlorine can gain that extra electron, and in that way they can form a bond which will be ionic bond, or you can say electrovalent bond. Okay, second way to complete the octet is by equal contribution of electrons, and in that way covalent bond will form. For example, here we took three atoms, carbon, oxygen, and oxygen. These blue dots are the electrons, valence electrons of carbon, and these red dots are the valence electrons of oxygen. Now, carbon have 4 valence electrons, and it needs 4 more to complete its octet, while each oxygen have 6 electrons, and they need 2 more electrons to complete their octet. So what they can do is each oxygen will share its 2 electrons with the carbon, so that they all can have their complete octet like this. And one more thing is each atom will share same number of electrons as much as it needed. Like the oxygen here needed 2 more electrons, so it will share its 2 electrons. The carbon needs 4 more electrons, so it will share 4 electrons. Okay. Third case is by unequal sharing of electron, and in this case our coordinate bond will form. Let's see, we took an example of NH3 ammonia and a H positive. Now this H positive don't have any electron to share, but it also wants to complete its duplet. So, and what it can do is nitrogen can share its electron with hydrogen, so that initially only nitrogen have 8. Now both nitrogen and hydrogen have complete 8 electrons. Sorry, it will have duplet and it will have octet. This is unequal sharing of electron, and this is the coordinate bond. So the difference between covalent and coordinate bond is, in covalent bond there will be equal sharing of electrons from both sides, and in coordinate bonding there will be unequal sharing of electrons from both sides. Now there are some exceptions of octet rule. First one is electron deficient molecules of hypovalent or lower octet molecule. Molecules in which central atom has less than 8 electrons in its valence shell. Now, there are many molecules in which the central atom don't have complete 8 electrons, but they are still stable. Example is PeCl2, where beryllium have 4 electrons here. BF3, where boron have only 6 electrons in total, so they will call like hypovalent. Second case is electron-rich molecule or hypervalent, or you can call it them super octet molecule. These are the molecules in which central atom has more than 8 electrons in its valence shell, and mostly the elements of third period and onwards form such type of molecules because they have vacant d orbitals present in their orbitals. For example, here PCl5, phosphorus have a vacant 3d orbital, so it can easily accept electrons in that vacant orbital and can make bonds more than 4. And this molecule, even after reaching the limit of the octet, it is still stable because of larger number of bonds. As I told you, whenever 2 atoms make a bond, they will lose energy, and more the number of bonds, they will lose the energy, more they will be stabilized, you can say. Some more examples are SF6, XeF2, IF7. See, in XeF2 you may get confused that there are only 2 side atoms, then how is it superoctet molecule? See, Xe have 8 electrons. If it shares 2 with fluorine like this, rest will be lone pairs, okay, like this, and fluorine will have 6 more electrons. So fluorine will have its octet complete, while xenon will have 10 electrons. So it will be a superoctet molecule. Third case is odd electron molecule. These are the molecules in which central atom has odd number of electrons in valence shell. And it can be because, let's say, nitrogen have 5 electrons in its valence shell. And if we can like take the example of NO2, nitrogen have 5 electrons and each oxygen have 6 electrons in its valence shell. So total there will be 7 valence electrons, which are like you can say odd number of electrons. And whenever there is a presence of odd number of electrons, the molecule will be paramagnetic. And if there are even number of electrons, each paired, then that will be diamagnetic. We will discuss that later. Okay. For to be like in order to be diamagnetic, each electron should be paired. There are some more examples like ClO2, Cl3, etc., which will have odd number of electrons. Fourth case is cation having pseudo inert gas configuration. Cations which have 18 electrons in their outermost shell will come under this category. For example, zinc. Now the configuration of zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and 4s2. If we remove 2 electrons from here, so 4s2 will be removed. That will be vacant. And now the valence electron will be from 3s2, 3p6, and 3d10, which is total 18. Okay. Now let's see some questions. Which of the following is not an exception of octet rule? To take care of this not. So let's see. SN2, SnCl2. Tin is from carbon family, having 4 electrons in its valence shell, and it will get 2 electrons from chlorine. So you can say that it is an exception of octet rule. If we talk about ClO2, Cl is from halogen family, so it will have 7 electrons. Sorry, let me write it here. And each oxygen will have 6 valence electrons in it. So now in that case, the chlorine have total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons, which is a case of odd electron system. That's why it's again like you can say exception of octet rule. In BF3 boron, we just saw the example that it's like incomplete octet having 6 electrons. See, it's again an exception of octet rule. Now, if we talk about SnCl4, since tin is from carbon family, it will have 4 electrons in its valence shell, and 4 electrons will be given by each chlorine atom. So total 8 electrons. That means the octet of tin and all the chlorines will be completed. So it is not an exception of octet rule. So answer will be second one. Now, in the next question, which of the following oxide of nitrogen is an odd electron molecule? For that, you have to just add on their valence electron, their total number of electrons which are present in their outermost shell. So in nitrogen, there are 2 nitrogens, each having 5 electrons in its valence shell, 3 oxygens, each having 6 electrons in its valence shell. So total will be 28, which is an even electron case, not an odd electron case. In this one also, this will comes out to be some even number. This will also be an even number, but in this case, there are 5 valence electrons in nitrogen and 2 oxygens, each having 6 valence electrons. That means total 17 electrons. So this will be the case of odd electron rules. Hope you understand this. Thank you so much.